In this video, we'll be going through a quick way of determining the expression for the inverse hyperbolic functions, namely the inverse hyperbolic cosine of x, cosh of x, and the inverse hyperbolic sine of x, sine of x. So I wrote down the equation x equals cosh of y, and our goal is to determine the expression for y as a function of x. Now, it's important to be rigorous here, because if we remember the graph for the hyperbolic cosine, we remember that the range of cosh is from 1 all the way to infinity, and therefore x has to be greater than 1. In other words, because the hyperbolic cosine of y only has values ranging from 1 to infinity, the inverse hyperbolic function its domain will be from 1 to infinity, because they're inverse functions. And so just as an aside, it's important to remember the graphs of key important functions, because they help you determine the domain and range of their associated inverse functions. So for example here, the graph of the hyperbolic cosine helped us determine the domain for its inverse. Now we can start determining the expression for y. So one key expression we will need to use is the fundamental identity when it comes to these hyperbolic functions, which is that cosh of x, cosh squared of x, minus sine squared of x is equal to 1. However, here, since we're working with x equals cosh of y and not y equals cosh of x, we need to replace x by y over here. And the reason I wrote x equals cosh of y is because we have y equals the inverse hyperbolic cosine of x. And it's just a question of notation here. Now, since we have cosh of y is equal to x, we can replace cosh squared of y by x squared. And therefore we have x squared minus sine squared of y is equal to 1. In other words, this means that sine squared of y is equal to x squared minus 1. And therefore sine is equal to the square root of x squared minus 1. The plus or minus square root. So now we have the expressions for cosh of y and sine of y. And I'm going to give a little hint here. The expression for the inverse hyperbolic cosine of x involves logarithms. And therefore, we need to use an identity that we know related to hyperbolic functions, which involves the exponential. And so we can take the inverse function, which is the logarithm. And the reason why the inverse hyperbolic cosine of x involves logarithms is because if we remember, the expression for cosh of y involves exponentials. Indeed, cosh of y is equal to e to the y plus e to the minus y divided by 2. And the expression for sine of y is e to the y minus e to the minus y divided by 2. And therefore, since it involves exponentials, the inverse of these hyperbolic functions will involve logarithms. And one key important formula is that if we add cosh of y and sine of y, we get the exponential function. Indeed, we have e to the y plus e to the y over 2, which is equal to e to the y. And e to the minus y over 2 minus e to the minus y over 2 is equal to 0. And therefore, we have that cosh of y plus sine of y is equal to the exponential function, is equal to e to the y. Though we know that cosh of y is x, and sine of y is plus or minus square root of x squared minus 1. And therefore, we can rewrite the expression as x plus or minus square root of x squared minus 1 is equal to e to the y. But we want an expression of y, not e to the y. And therefore, what we do is take the logarithm. But first, let's be rigorous. We know that x squared minus 1 is greater than 0. because x is greater than 1, and therefore x squared minus 1 is greater than 0, and therefore the square root is defined here. Moreover, x plus or minus this expression is always greater than 0. Why? Because we know that x squared minus 1 is less than x squared, and therefore if we take the square roots, that x is greater than square root of x squared minus 1, and therefore x minus square root of x squared minus 1 will be greater than 0, and hence we can take the logarithm on both sides, which means that y is equal to the natural logarithm of x plus or minus the square root of x squared minus 1. And so this is the expression for the inverse hyperbolic cosine of x. And so just as a little recap of what we did here, first we decided by convention that x would be cosh of y and that y would be the cosh minus 1 of x. And then we made sure of the domain to be sure that the inverse is well defined. And then what we did is we used the hyperbolic identity cosh squared minus sine squared is equal to 1. And therefore we had that sine of y is equal to plus or minus x squared minus 1. And therefore, and afterwards we used the identity cosh of y plus sine of y is equal to e to the y. And the way we obtained this expression is using the formulas for cosh of y and sine of y, which is related to the exponentials. And this allowed us to determine the expression for y, which is equal to ln of x plus or minus square root of x squared minus 1. So we obtained the expression for the inverse hyperbolic cosine of x. However, we can rewrite this expression over here in a different way. Indeed, x minus square root of x squared minus 1. We can rearrange this expression, and the way we do this is by multiplying by the conjugate, x minus square root of x squared minus 1, multiplied by the conjugate of this expression. In other words, we turn this minus sign over here into a plus sign. So x plus square root of x squared minus 1 divided by x plus square root of x squared minus 1. And so this here we can factorize or distribute. And we obtain that it's x squared minus the square root of the square of this. So minus x squared minus 1 divided by x plus square root of x squared minus 1. And so this cancels out with this, and all is left is minus 1, which is 1. And therefore we get 1 over x plus square root of x squared minus 1. But the natural logarithm of this expression over here is just equal to minus ln of x plus square root of x squared minus 1. Which means that this minus sign over here, we can bring it up all the way here in front of the ln, which finally means that cosh the inverse hyperbolic cosine of x is equal to the natural logarithm, the plus or minus the natural logarithm of x plus square root of x squared minus 1. And so obviously this might have seemed as a long process, but the reason for this is because I wanted to fairly and thoroughly explain the reasoning behind how we obtained the expression for the inverse hyperbolic cosine of x. But all we needed to do is use a couple of hyperbolic identities. And we eventually got the expression for the hyperbolic cosine of x. And in the next video, we'll be using the same exact process to determine the inverse hyperbolic sine of x, which you might have guessed also involves logarithms. Thank you.